All right, we are dealing with rational exponents. Rational exponents. That means the exponents are going to be fractions. Okay, exponents are going to be fractions. So the typical exponent you're dealing with, that's the power. Okay, that's the power. So the typical exponent, you like x to the fifth, right? So you're used to exponents that are integers. So like x to the fifth. So when they say power here, that's the 5. All right. And then the root, you know what a root is. When we have a root, we have something like cube root of x, right? So that's the root. So now we're going to mix those two. We're going to make a fractional exponent, and it's going to be power over root. All right. Now the first set of examples are going to be just rewriting. So there's no simplifying here. There's no calculations. We're just rewriting. So we're taking one form, right? So this is the radical form, where you have the square root form, where you have the radical there. So this is the radical form, and this is writing it with rational exponents. So radical form, rational exponent form. So here, right now we have the radical form because of that symbol, and we're going to rewrite it, right? So here the base is 7, the power is 3, and the root is 4, so we write 7 to the 3/4. And that's all I'm asking you to do for the first set of examples. Example B, the base is 6, the power is 1, the root is 2. So this is the one place where if they ask you, if you remember, usually in math when we say if you don't see a number, assume there's a 1. Well, this is the one place. If you don't see a number, assume it's 2, right? This is the square root, so it's a 2 there. The root is 2. So this is 6 to the 1/2. Right, so C, there's no exponent, so it's 1. Right, so that's the one place. Remember, if you don't see a number, assume it's a 1. So this is x to the 1, and the root is 3, so it's 1/3. X to the 1/3. Going on to D. And don't be afraid of parentheses. So I'm going to go ahead and use parentheses. So x plus 2. The power is 2. The root is 3. So that's 2/3. 2/3. That's it. E. All right. Put 3x minus 1. And not really sure why they have parentheses here. Usually, when there's no other exponent, we'll just write that as 5th root of 3x minus 1. Okay. But that's how it's usually given. Not sure why the parentheses are here. But anyway, this is going to be to the 1/5 power. But I do need to write the parentheses when I switch forms. Okay, so I have to have the parentheses when I switch forms, because it doesn't make sense to just have 3x minus 1 and then 1/5 over here. Right? This makes it look like it's only 1 being raised to the 1/5 power, and that's wrong. Okay, here you need the parentheses. So just whatever's inside, including the exponent, you're raising it to the 1/2 power. Okay, so this is not 3. It's not x to the 3/2 because it's not this. This is not the answer. Some of you might think that's the answer, but what's happened is, and this is wrong. This is wrong, right? So this is the correct answer. That's the correct answer, and this is the wrong answer. This is wrong, right? So you might think this is correct because you got 3 times a half is 3/2, but this 3, well, there's no half on the coefficient of 3, so that's what makes it wrong. If you had like 3 to the 1/2 like that, then that's closer to the answer. Well, that would be acceptable, but this is perfectly okay. When I'm all asking you to do is rewrite it, that is perfectly okay. All right. In the next set of examples, we're going to change the form. Right? So now we're going to go into radical form. So here the root is 7, so it's the 7th root of x squared. Yeah, that's it. Right? So the power is 2, so it becomes x to the 2nd. Now this could be written also, well, 3, with parentheses and then the 2 on the outside. That's perfectly okay. So either answer is acceptable. All right. And so in other words, the power of 2 can be inside the radical, it could be outside the radical. Either one's fine. Going on to B, x to the 1/4. So this is just a root this time, so it's 4th root of x. And that's it. And 3 to the 1/2, that's a square root of 3. That's all that is, right? No other power. So that's a root, so it's square root. Then D, 3/2. So it'll be square root. and x minus 4, and you could do the cube on the outside. So that's one way to write it. Another way to write it is square root, put the parentheses on the inside, and raise it to the third power. So that's it. Either answer is acceptable. When I'm doing a rewrite, I prefer the second method, but either method is fine. I mean, there's nothing wrong with the other one. When I'm doing a simplify, when I'm actually working things out, I tend to use the other method. Okay? E, 5x squared to the 1/3, so you're just going to do a cube root. You just put 5x squared, the whole thing that's in parentheses, in the radical. And that's it. F. So again, there's two. So this one had the power or the numerator of 1, so there's no other parentheses. You don't have to raise it to the first power or anything like that. You can just leave it like that. This one has a non-1 numerator, so you're going to write either 2x squared plus 1, the 5th root, and raise that to the 4th power, or you're going to have 5th root and put inside the parentheses 2x squared plus 1, and then raise that to the 4th power. Either one is fine. Either one is acceptable. Okay. All right. So those are the examples. And then here, simplify. So the whole point of doing these rewrites is because of the way we think, right? When I see a square root, my mind goes a certain direction. So when I see this example, it's 25 to the half. So until you have more experience with it, you're like, well, what's 25 to the 1/2? But you know that can be written as square root of 25. And then as soon as you see square root of 25, oh, you know what that is. It's just 5. And that's what I mean by simplify. So so these can be simplified in that way. Here, you now have an exponent with an exponent. And whenever you have that situation, all you do is multiply the exponent. So 6 times 3/2. And to multiply fractions, remember every whole number has a 1 underneath. You're going to multiply straight across. So that becomes x to the 18/2. Reduce to 18/2 and you get 9. So the final answer is x to the 9th. C. Looking at this, you're going to reduce that exponent. 4 over 2 reduces to 2. So what you have is 6 squared. Well, 6 squared is 36. So you are expected, if the number is within reason, when I say within reason, something you can handle mostly in your head or even a simple calculator. If you get answers like 2.7891 blah 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 blah, you can just leave it. Like you don't have to give me that nasty decimal answer. Or if you get a 12-digit whole number, okay, you can just give it to me in exponential form. All right, I don't think that's going to be very common though. All right, so here, this one's going to be confusing because what I have here, I'm going to have to take this exponent of 2/3 and distribute it to the two things inside. So it's going to say 64 to the 2/3. And I'm going to do x to the 3rd to the 2/3. So what I've done is I've taken this outside exponent and I've distributed it to the two things inside. So 64 to the 2/3 and x to the 3rd to the 2/3. Now the 64 to the 2/3, I'm going to rewrite it. Uh-oh, my computer just froze. All right, okay. All right, so what I'm going to do is rewrite this. So this is the one you want to rewrite it with the root first and then the power. Because what you want to do is reduce the size of the number, and roots make the number smaller, okay? Over here, all I'm going to do is just multiply the exponents. So 3 times 2/3 is 6/3, right? 3 times 2 is 6, and you don't do 3 times 3. You only do the top. Remember, every whole number has a 1 underneath, so it's 3 times 2 and 1 times 3. That's why it's 6/3. Here, what's the cube root of 64? Cube root of 64 is 4, and yes, you're allowed to use a calculator. I'm going to reduce this fraction. That's a 2. I know what 4 to the 2nd power is, and yes, you're expected to do that. So you got 16x squared. Final answer for D. All right, moving on to E. Do the same thing again. So it's going to be 64 to the 3/2. And it's x to the 4th to the 3/2. All right, so here, 64 to the 3/2. We write it as square root of 64 and raise that answer to the 3rd power. Here, I'm going to just multiply the exponents. So that would be 12/2. 64, square root of 64 is 8, so now it's 8 to the 3rd. And 12 over 2 is 6. 8 to the 3rd is 512. And that's my final answer. Alright, F. 343x to the 9th. So I'm going to distribute that 5/3. So it's 343 to the 5/3. X to the 9th to the 5/3. Alright, so 343 to the 5/3. So that same thing is cube root of 343 raised to the 5th. Here, multiply the fractions. So it's 45/3. Alright, cube root of 343 is 7. Reduce that fraction, it's 15. Now, I do not know what 7 to the 5th is. This is my third time doing it today, and I still don't remember what 7 to the 5th is, so I'm just using the calculator. And it's pretty big, but it's still reasonable. 16,807 is what the calculator told me. And that's the answer. And that's Monday's lesson. Okay, hope you're not going stir crazy at home. Bye-bye.